Hello everyone, welcome to my presentation on Embedded System course project. My project is about creating breathing pattern monitoring with piezoresistive sensor. I am Mohammad Sabbir bin Zaman and I am an electrical engineering major. Breathing pattern monitor is intended to monitor how the person's breathes over time. It is a useful tool to monitor patient's health condition by observing his or her breathing graph. I propose to build a hardware that can read breathing data with a piezoresistive sensor and send it to computer for plotting the pattern for visualization. For that purpose, I designed a PCB using Cadence Allegro PCB editor, and I developed the software for the microcontroller, which is MSP430F2232. I soldered the components on fabricated PCB and I tested the hardware in real-life situation. I divided my presentation into the following. At first, I would like to show you my complete block diagram that I used to implement my project. Next, I will show you selection criteria for cutoff frequency of low-pass filter, which is LPF. From now and onwards, I will use LPF instead of long-word low-pass filter. Coming next is the schematic of the designed LPF and its simulation results. Then I will go through the important components of the hardware that I chose. Then comes the complete schematic of the hardware, then real PCB ordered for fabrication, then PCB with components mounted on top and bottom layer. Then comes the arrangement made with Arduino Uno board to collect data from the device I designed for the MATLAB plotting and the MATLAB plot, and finally the presentation ends with a conclusion. In order to walk you through my project briefly, I plan to use this block diagram. At first, the raw signal will be conditioned using LPF of 5 Hz cutoff frequency and converts the analog signal within 3.3 volts so that the ADC of resolution 10-bit of the microcontroller can convert the analog signal to digital. Every time ADC completes its conversion, it produces an interrupt, and the processor then scales the corresponding digital data, which is between 0 to 1023. It scales it between 0 to 10. The microcontroller then used its UART peripheral to transfer the scaled data for data acquisition. For data acquisition purpose, I used Arduino to collect data. Later, Arduino serial transmission is picked up by a serial port application named CoolTerm, which I will show later, which helps me producing a text file with the data it finds in the connected serial port. My MATLAB code reads this text file and plot the data on the computer screen. And here is the criteria I used for cutoff frequency selection. I found the breathing rates of different ages from the Wikipedia. Here is the plot from where we can see the maximum possible breathing cycle that includes inhalation and exhalation is 60 per minute. So it concludes that we need to design a low-pass filter with 1 Hz cutoff frequency, but I designed a 5 Hz low-pass filter to materialize my selection. And here is the filter I designed using Cadence Capture CIS editor. It is an 8th order Butterworth low-pass filter. And as you can see, the simulation results from the LPF. It's a body plot of gain in decibel versus frequency plot. The red arrow is identifying the cutoff frequency for the filter, which is 5 Hz. The advantage of this LPF is that I can avoid designing a 60 Hz notch filter, since this LPF is already impeding the signal of more than 5 Hz. Here is the important components I want to describe before I go into the deep. First one is the piezoresistive sensor. It converts force it faces to a corresponding resistance, and we use excitation of 3.7 volt to convert the resistance to voltage by using a voltage divider. Here is a microcontroller I used for the project and the op-amp I used for designing my filter. And here's a schematic diagram for the complete hardware. You can see the header for the sensors, power, serial data transmission, and the JTAG for debugging and also programming the microcontroller. Now is the PCB I ordered, which has several mistakes printed on it. There were some places where there are solder masks, but it shouldn't be there. I later had to scratch with knife and tweezer to clear some of my pad stacks. Since the ordered one did not have drills for some pad stacks, I soldered wires on the pad stacks and used breadboard to connect my PCB to Arduino, and of course for programming the microcontroller. Now you can see the final version of the PCB with components mounted on it. You can see the wires I used instead of JTAG connection and other communication purpose. And here is the picture of Arduino arrangement, and for the data collection using Arduino from the hardware, I used serial monitor named CoolTerm. I didn't use Arduino serial monitor since the serial monitor does not allow us to store data in a text file. I stored the data in a text file. I used MATLAB to read that data and plot it later. And here is a video which shows you the collection of data from the hardware. I used, which I already mentioned, that I used CoolTerm serial terminal application to collect the data from the Arduino, that the Arduino receives the data from the PCB that I have designed. So take a look at the video. Here is the data. It is collecting every time, and now I'm saving the data as a text file, which I will be using later to plot the data using the MATLAB. Now you see that I am going to rename that with the extension of .txt file, since it is saving the data as a .asc file. So I'm just changing the extension of that file from a.asc to .txt. Here you can see the text file with the data all over. And then here is the way I used my MATLAB to plot that data. You can see the video of it. I'm just copying the text file that I created using the CoolTerm, and now I'm pasting into the same directory of the MATLAB script that I'm using to plot that. Now you can see the output that it's showing. But unfortunately, I could only collect data for a few cycles. And after a few cycles, it's not showing perfect data anymore. I don't know the reason perfectly. But to conclude my presentation, I will share some of my experience I gathered from my mistakes. I should have been more careful and cautious while designing my PCB. In some places, I designed footprints for 0805 size components, but later I found that only available and cheap components are of 0603 sizes. It created a lot of problem for me. I had to solder some traces manually to connect some of the components. Maybe because of that, my project failed to monitor continuously for more than few breathing cycles. Thank you very much.